welcome to my talk. Nice to see some interest here. It's a pleasure to join. It's my first time here in Malmö, in Øredev. We have an office in Lund, as you might know, Volvo Cars. And I have a lot of friends, developer friends in this region. I wish I would visit more often. I live in Gothenburg. And I work at Volvo Cars, and my name is Johannes Foufas. I have some title at the moment, lead architect software or software factory. And I will talk about our DevOps. Our DevOps CI for the source code that we put into the car, in the car platform. So not the, retail systems or web frontends and so forth. So this is, I will talk about our CI system that we use for the code we put into your car or cars. So first I thought I have to put the commercial before the black slides with text, basically. So this is a EX90 that we put a lot of focus on at the moment. It's an extremely nice car, I would say. And I just Googled, I stole the topic, the headline from this, from my friends in the Zuul project. So I just Googled a random picture and I found this. I thought it was really funny. So in case someone wonders, like, why did they call their project Zuul? There is some references for, maybe some people in my age group would know. It's not a dinosaur, at least. There is a dinosaur called Zuul, actually. So the topic is about, I will talk about how we use Gerrit, the code review system, and that came from Google. I think they made it for Android, and it's something that we use. Zuul, the CI/CD system that originated from the OpenStack project. And I think most people might know that, open infrastructure. It used to be one of the largest open source projects in the world. And they branched out Zuul as its own project within that ecosystem of OpenStack that then became Open Infra. And then I will also talk about how we are now incorporating Bazel from Google and why we do this. So, because these things, they kind of go together. So as I will explain, the CI system easily becomes a build system, and how do you incorporate your code review system in a good way with the CI system if you have certain constraints that we have and you might have also. So in this URL down here, we actually got our own tenant in OpenDev. So we put our first Python project public, or our first project within OpenDev. So we were allowed to, because we have a little build system that we use for embedded ECUs. And we needed to put it open source, but we needed our CI system. And we couldn't use our own cost of security and so forth. It's not good to, put your CI system publicly on internet, exposure and all that. So they kindly offered, a tenant. So we have a place where we run one of our build systems on. So if anyone is interested, you can check that out. So I will describe what we are doing currently in a 3-step a three-step approach. So I showed the logos, with these three things. And the first step is Zuul. And this is a snapshot of the web GUI, how Zuul looks for the developer. There is not a lot of GUI in Zuul. Very little, actually, if you compare to others. But this is one of the views that if you push something as a developer, you would probably, and maybe you're stressed or there's a deadline, you would look here, like how is it going? If you just throw things in Gerrit or GitLab, you would look in your code review tool, of course, and you would get some messages. Oh, this went that, and then you can press a link and have your logs basically. But this is the web GUI, and so the reason we choose this kind of, I wouldn't say odd, but not so common CS system is because of the requirements we had. So if you look into the left side of this picture, you see like a simplified architecture of a car. And nowadays, it's actually a rolling data center, more or less. It's becoming a data center, and it's, there can be hundreds or at least 100 of these computers inside. And some of the strategic ones are often developed in-house, what we call in-house development. So that's kind of a vague term. What is that? It's not that we're owning 100% of all the code within, but we might own parts of it, or the interesting parts. So it's varying. And when you have multiple computers in this system, some of them are POSIX systems nowadays, and some are like classic embedded ECUs, and they have to communicate. And you have a wide range of developers from all over, in many sites, in many teams, and their coding standards might vary. Actually, in the car industry, I usually joke sometimes we can take anyone from the street and say, here's a computer. But there are also some extremely skilled developers, of course, but they depend on each other. So these computers depend on each other, and we looked around and we said, we need something called gating. Nowadays, when we started to look at this, I think 7 years ago, we searched the internet. We need something gating. We need something, a quality thing that you have to pass before we merge your Git commits. Because we really need to ensure that things are working before they're landed. Nowadays, I think this is standard in most DevOps systems, in most CI systems. This is standard. But we found this, and then when we looked at the OpenStack project, they had a really complex project. They are putting together, cloud systems and measurement systems in different configurations with the same code base. And it's extremely complex. And you can create an account in Øredev, and push your code basically, and see, if it lands. So anyone can join and contribute. So what Zuul has is that, which I think is still a bit unique, is that you can depend on other teams' changes and still have your gating. So the typical pipelines in Zuul are check and gate. Check is when you push your commit, and gate is when somebody, maintainer or something, says, yeah, I want to merge this, this is ready. Let's try to merge it. And then usually we trigger the gate pipeline. And in this, and I think here, if you look at one of the dots there, you see there is like a green little dot up in the left corner of the GUI. There are like 2 repositories there, 2 changes, and the numbers are Gerrit commits, but they are from different repositories. And they can be from different instances of Gerrit. They can be from GitHub, they can be from GitLab and Gerrit. And as a developer, you can say, for instance, I'm building something, but I depend on this team's change. You just write in your commit message, depends on. And then Zuul will say, oh, nice. I will check out these changes and build something. And I will carry this change throughout check and gate. So you can have a strict gating system, but still people can still depend on each other. So that's, I would say it kind of enables a monorepo, but it extends between different code review systems, different servers. So this is a thing we really needed. So that's why we run this, or one of the reasons, I would say. Let's get through. These are some fresh stats. So in our so Zuul is it's quite highly scalable. There is a backend, a microservice backend for it. So it's a really scalable system, and the components are used for many tenants, and tenants is like a division. If you have a tenant, you have your own like web GUI. You have your own set of logs, And this is the biggest one, Volvo Cars Corporation, VCC tenant. Yeah. It's where the major development is for the car we saw in the commercial, for instance. And we get around, we peak on, 20,000 jobs each 24 hours. So it's not like super big, it's not like the major tech companies, but it's not super small either. And there are, I think last time I counted around 2,000 developers maybe engaging. Yes, so step 2 in the journey that we are now on is what I called a virtual monorepo. So we see that there are many benefits of having monorepo, having one repository for all your changes. Often, due to historical reasons, it's not possible, right? Starting from clean, not so easy. So with Zuul, we can have some of the benefits of a monorepo. But then, we can make it even better. So we can use something we call a virtual monorepo. And this is something we have that is under development, and there is a tool here written by one of our contractors and they put it open source. So this tool is that we are experimenting with creates a monorepo for the developer. So and that's what I try to write here or illustrate on the bottom. So you have your folder structure, folders. And the Zuul folder is where you have your pipeline definitions of your CI, basically, YAML files. Run this and run that. And for the developer locally, this is just a folder structure. It's really convenient. But when you push, you use this Git top repo tool. And all the folders, or most of them, are actually submodules, Git submodules. And we all have our, we like them or we don't like them. They can do things, but generally they're a bit cumbersome. But there is a feature in Gerrit, which is called super project subscriptions, which automates the use of Git submodules. So whenever you push something, there is like a top repo master, and there are submodules. They can be, mostly it's a flat structure. So there's like one top and then the others. And it's kind of automates the, synchronization of the submodule towards the master repo. So So this script here, if you use that to push, then the CI system will see it as submodules connected together. And yeah, Zuul and Gerrit are really, really tightly connected because OpenStack projects use Gerrit, and they are very active in the Gerrit project. So they follow it really closely. And Zuul is really, really connected to Gerrit. So Zuul has features that if you enable certain, I think I wrote it here, allow circular dependencies, which actually is bad usually. But if you enable this and you use a Gerrit topic, then Zuul will see this as an atomic commit. So, which means that Zuul will know that this belongs. So I have to, all of these submodules will have to move as a unified unit. So this is like why we nickname it a virtual monorepo. So yeah, it's not, but it solves the issue where you want to introduce something and you have some car launches going on and you want to make changes. And you can't just change the repository structures when you worked for 5-6 years. It's like, you can't even, maybe you can't even merge them. You can't touch them, basically. So what do you do then? Well, this is one of the things you can do. And then in the web GUI again, it will look a bit different. So it's like really tiny detail. So if you look at the bottom here, we have our current super project. It's called HP Super. And then we have the topics. So in this topic, we touch 3 different repositories. Not for the developer, but for Gerrit and for the CI system. So that's why they are bundled here. Usually there is only one Gerrit ID or GitLab merge request. But here we have 3. And then somebody was really efficient here or is really hacky. So they also have other changes on top. So they depend on others. And they could be a stacked commit that they are working on, or it can be that they depend on this and this change that my friend is doing, and I need this in order to develop the thing I'm doing. So I just add those up. And woof, there you go. And this is quite nice. So even though I personally don't like complexity, I actually hate complexity. The product is complex. There's nothing I can do about it. And this kind of solves some of the complexity. And I forgot to mention, if you have questions, I don't know how we are about time, but you can interrupt me for questions. And if we get, too dragged out, I have to maybe, save them for later. So step 3 then, in this 3-step rocket is Bazel. And Bazel is Google's own build system. It's the acronym of Blaze, as some of you might know. They open sourced it. You can read about it on the internet, but they open sourced it, and it's not easy to deploy. There are not so many people or companies, I think, who use it. Small startups, I don't think so. But if you have large-scale systems, then there is actually a benefit of using Bazel. And in America, a lot of the Googlers, they went to Meta, right? And they have back too. So they have kind of implemented the same. Because, one thing that the Google people seemed to like was their build system. I don't know if they like the code review system. I like Gerrit though, but I don't know. But there is a book published open source where they actually say they all love their build system. And it's Bazel. And this, I think, is a funny picture, at least for me. You can't see what it is, but this is actually a Zuul GUI. And I think it's like 1/10 or something of like a pipeline. And when you have something like this, you have done something maybe not so good. What you actually done is, you might have a lot of software modules that depend on each other, and then you make what Google calls a large-scale change, and then you need to rebuild them all. And you can do that with the CS system. And then it might look like this. You will get a very, very, very big build chain, and so I've tried to use some lines to describe this. So in Zuul, and generally any CD system, you have pipelines where you can specify your list of build and test steps. And those are great because you can run them in parallel, right? Even in multiple clouds. But this can become chaos if you start to model your dependencies between your software modules in your CI. I don't know if anyone has this experience. Maybe it's only me, but I've seen it. And and this creates an enormous complexity. And the DevOps engineers, they really have to work hard because it's the CS system starts to become a build system. And here we see that Bazel can take away a lot of this. So if we have a big stack, we might have hundreds of modules, and they all depend on each other, and they were developed by, I don't know, 50, 60 teams all around. And they depend on each other. Then you can model these dependencies inside of Bazel. Because Bazel is called an artifact-based build system. So you actually just specify the binary you want out. And then it's really, there's a lot of code you have to write in this star-like language, a subset of Python. You have to define everything, and this is like, some developers don't like it. CMake is nice. I can just do this, do that, and it's fast, and you can do magic. And in Bazel you can't. You have to write down everything, all the dependencies, all your, if it's C or C++, all your header file dependencies, and your, dependencies towards strange libraries, and the machine that you run, and everything. So this is quite cumbersome. But the good thing is that Bazel will keep track of the dependencies. So you don't have to do it in your CS system. It's held within the build system. And if you have a big like stack and a big monorepo or a virtual monorepo, and you do a change that will touch everything, Bazel will calculate, I need to build this and this and run these tests. So it has a like build and test avoidance built in. But not only that, this is, I would say, how do you say, simple, I shouldn't say management-friendly picture, but yeah, maybe it is. Yes? Yeah.
Is that different from, Makefile also has dependency.
Yeah. Yeah.
What does Bazel do that Makefile?
Yeah. I think this picture might explain it. Bazel has everything is defined and has hashes. So of course, you have dependencies in other build systems, but there is on YouTube a very nice picture of, I think it's SpaceX. Many years ago, they explained why they changed. If you do a production build, they do make clean, because things can happen, when you do a production build. And if they do, and if it's a rocket, you might be out of business. But Bazel have everything has a show ID, has a unique identity, and the build system keeps track of this. So that means that, and this picture is like a local developer. You just Bazel build your application or whatever, and Bazel calculates the actions needed to do. It needs to do. Maybe it needs to, create rules, check rules, and compile and so forth. And then you have a local cache, and you can trust it basically as a developer. And then, since it's very strict and it's sandboxed, and if you do if you control the system in certain ways, you can ensure you don't have cache poisoning. And this is actually the magic key, I would say. So you can share the cache in the cloud. So developers can share with each other, and they can share with the CI system if you do this in a right way. And this is extremely powerful, because if you built it once, it's cached. And this gives this powerful speed up that you can get with this system. And that's why you go through the hassle of, defining everything, and because you can get extreme speed ups. And it also has some other thing here called remote execution. And it abstracts away, or it can abstract away, the hardware you're running on. And you can set the default, like just RB, like remote execution. And then you can have a cloud backend. So if you have a large-scale change, you can have as many cores as you need. Usually we have one core for action. And, if you need 100,000 cores, you can have it, if you can pay for it. I mean, if you have the capacity. But if you do, you can have that. And that is something I think is, really, really, really powerful. Here is another picture. We have experimented with this remote execution environment. Maybe I shouldn't go into too much detail about that, but we are trying something called Build Barn. So it's another open source project. It's maintained by a person called Ed Schouten. And we use it in one of our owned companies that we have. And it's extremely powerful. It is not very easy to understand. And it's, it doesn't maybe give you a lot of logs. So if you have to maintain it, it's, but it is extremely fast and extremely potent. So with a remote execution and cache system connected to Bazel, you can actually you can actually have a default, like the developers, don't use your local laptop. Use remote execution. Because if you do, we don't get cache poisoning, because we control the image you build from. So you can't include something fishy that makes it work on your computer, because it's our image. And what we give in return is extreme power, basically. I don't know, maybe I shouldn't, this is, I don't know. I don't know if it's an architect diagram. I don't know. I'm not really an architect. I don't know what I am. I used to be a developer, but so this is. I tried to kind of explain how it works. Up here we have a Kubernetes cluster with the microservices of Zuul. We have another cloud, and here is one cloud, and we have Gerrit. We have an Artifactory, binary storage, and we have changes that spins up pods in Kubernetes or EC2 VMs in this case, and run jobs and run reports back, and to Zuul, which reports to GitLab or Gerrit, mostly Gerrit. But in our new system that we now are getting closer to get into production, and the 3-step things I'm showing for you today, we have something really, just a second. We have bare metal machines. And this is something really interesting. So we have 2 developers who are using open source products to create micro VMs. So we have a big bare metal machine that spawns micro VMs that boot in a second. So they have nothing. You have to install. It's the kernel. It's like a bare kernel. And you install the things you need, SSH and so forth. And then those invoke Bazel, which is the build barn cluster underneath here. So that does all the dependencies and the actual build system actions, and then reports back to the bare metal. And why do we do this? Because the bare metal micro VMs, when they're ready, we snapshot them and put them in S3 buckets. And that means that when we invoke them again, if we do it correctly, their RAM is intact, which means that they don't have to do a lot of dependency analysis. They are fresh. It's like your local laptop, in the old Make days where I used to program. If you do incremental things, it's quite fast. So and you can have the same thing in a Kubernetes-based system where you invoke something and then kill it, which this is. Yeah, these are some explanations then of how Bazel works. So there are 3 phases when you invoke Bazel. You have the loading phase, analysis phase, and execution phase. And some years ago, or I think in the beginning, they were separate. But now, when you load, the analysis phase starts. But as soon as the dependency graph is executed and it knows how to do something, it starts. It's execution. Now we can have the question. Sorry, I forgot. Yes. I think that in big companies this is very common, and there are many reasons. I don't work with IT, but they might want many, and they have some teams maybe who prefer one thing, and you have a smaller project, and maybe you need something in one cloud provider, and then there is maybe you don't want to be dependent on only one, and so you can have many. And we have a lot of bare metal also. I mean, we came from bare metal, and then they said, oh, there is a cloud provider. We're like, oh yes, I'm gonna not be a server maintainer anymore. Maybe I will survive until 65. So and then we just got one, basically. This is what you get, and we just took it. We didn't have any choice or anything. We just like, oh, cloud, wow, fantastic. And then came another one, and but yeah. So that's how it goes. Yeah. So these are the phases we have in Bazel, and this is, I think, really nice. Like, it looks like some kind of trace thing, like you would get of Chrome. It's from another tool, which is open source, connected to Bazel, called BuildBuddy, and they offer some of their things are open source. And when you make a remote executed build, you actually get these nice reports. And here you can really scroll and see what happened in your build. And if you have 2,000, 3,000, 4,000 actions, it might be nice to be able here just to scroll and see, why did it take so long, or why did it fail, and so forth. And here, I don't know, maybe my eyes are bad. Yeah, it says critical path. So when you have this system, you're actually, you often want to be close to what Bazel says is critical path. So let's say you have 1,000 actions, that can be parallelized. Bazel says, oh, I can run these in parallel. Nice, I need 1,000 cores. But the longest, the time your build takes is dependent on the longest of these 1,000. And that's the critical path. So you always get this number. So you will know how much slower am I than critical path. So you always see this here. And for this example, I think we have 1,600 cores in this change. And the critical path was, I think, 1 minute, 40 seconds or 60 seconds. We were like 2 minutes or something. And we had 4,000 actions or something. So, yeah, this is something that we get along when we use these open source products that are really, really nice for developers. Yeah, this is something about the vision of what we're doing. So the 3-step things I showed you now is what I'm actually been working for this year. Is what we're trying to change within Volvo Cars. And this picture here is from a conference in Gothenburg, last conference we had. And here is Alvin Bakkenes, he's head of software at Volvo Cars. And this is from his presentation. So I just took a photo of it. And he just, showed the vision of what he wants to achieve, what we should achieve as a company. And it's expressed as Bazel build car. So we, it would be make car for us, all this. But in Bazel, it's Bazel build and car. So the vision is that for all in-house nodes, a developer should be able to build the whole stack from command line. And it doesn't matter if the complex data center you saw in the beginning of the presentation, it should build from command line. And with Bazel, we could actually do this. Because with Zuul, with the virtual monorepo, and Bazel, we could actually put most critical things, and we had the compute power to do it. So if you actually changed everything, we could build it with brute force. So this is our vision. This is what we are aiming for, and of course we are not there yet. But it's and here it is again. So it's great to have a vision where we're aiming. And how are you about time? I think I forgot to set the. 4 minutes. Yes.
In the CI/CD system, you also have like test scenarios.
Yes. Yeah. And this demo here is when me and two colleagues actually explore this new system. So here we have a platform code change, and we run it on a laptop. It took 45 minutes. And then we said, okay, so let's run it now with remote execution in our cluster. And then we disable the cache, because you don't want to cache. So now we want to see how much muscle do we have. And it was in the morning, 8 o'clock. Nobody of our team, we're developers that work with the Bazel conversion, were active. So we had the system, it was fresh. And, we pushed the change here. You can see in the Grafana dashboard here in the middle, on top there was like or in top left, on the up top right, there you can see the amount of cores, the actions. And first action was like 600 cores. So we said, okay, let's run it again. 1,200 cores. Third time, 1,600 cores. And here at the moment we had 620 tests, and they run like in 2 minutes 40 seconds. Locally it took 45 minutes. With the old build systems, it would take long. But with remote execution, we actually came close to 140, so two something. And the system, listened to our queue and scaled up. So the build barn is a Kubernetes cluster, and it's auto-scaling. And it scaled up, and we realized, it's actually, and I had to talk with a guy who set it up, and like, it's fully enabled. Yeah. Oh, nice. Yeah, we tried it. It seems to work. Yeah. It's great. So, it's there. When I saw this, I was like happy for a few days, because this is, to later, maybe start of next year, give this to developers for real, that's what I work for. That's why I work with DevOps, basically, to make developers happier. Yes? Hardware in the loop. You mean with Bazel? Yes, if it's not flaky. So the thing with the remote cache is, if you have flakiness and you have the wrong kind of flakiness, you have success, right? And it's cached. And, the CS system won't touch it, right? So what if it's a flaky that was actually serious? You didn't catch it. So yeah, you have to keep track of your flakiness. But if you have tests that have low flakiness, yes. And it's an enormous, when you have a heel rig park and you want to optimize, and you only have to do a thing once. Resource utilization, it's... if you Google on the internet, there are companies who actually have custom bare metal servers with their target software, which uses Bazel, and this was just the data. I think we're more or less out of time. These are maybe I should touch on this instead of talking about Bazel. So the Zuul project is based in Open Infra Foundation, and we really appreciate to have our CS system. Even though it's Python, it's slower than Go or C++, but it's very easy to engage with. And it's an active community, which is really friendly, where our developers can engage if they like. And also, being open source, if we need something, like for instance what I showed you now, maybe we need something, a new feature, we can develop it, push it upstreams. And that's what we did with, so we have a enterprise version, we call it, that we have one of the founders as a consultant, and he helps us to push things upstream, which means that, we can take part of it, our developers can take part and meet other developers and develop their skills in an open, nice community. And, we can have the founder help us, to push things upstreams to help us. So I think this is actually one of the other big reasons that we choose open source tools, that are a bit maybe odd. It is because they are, Zuul is truly open source, they try to be it in whatever they use. And for us, it has these benefits of engaging with an open source community. So I think, are we out? Time? Yeah, we are. I managed to talk and I skipped some slides even. So thank you very much. Lund, Malmö.